So I want to try to give you a short summary of the core algorithms of machine learning. And there are not that many, really. It is classification, clustering, regression, and then essentially variations on optimization, right? So classification essentially says identify and classify the data by various boundaries and domains, so it naturally separates out. And it's a very useful set of algorithms, right, that enable you to classify the data and to find what the natural boundaries are, and there may be very interesting insights when you classify the data. The next set of algorithms are what you call clustering algorithms. Clustering algorithms look for centroids of groups. As you look at data, you say, is there a natural cluster, like bunches of grapes, right? Classification is where you have apples and pineapples and grapes and maybe cauliflower. And then the algorithm says, wait a minute, we can classify them as apples, as pineapples, and maybe as grapes, and maybe as cauliflower, and that's a clear vegetable, it's actually not a fruit. So it classifies the fruits and vegetables. Clustering, on the other hand, if you look at a vineyard and you see, oh, there's a bunch of grapes, there is another bunch of grapes. So it is finding those clusters, those grape clusters we are so fond of looking for, and they communicate different things, right? You find that some clusters are much luscious grapes. They've grown well with the sun. You may look for reasons. Why did these grapes, this cluster, look so healthy? And you say, oh my God, it was in the bright sunshine. Another cluster maybe was in the shade, and you say that wasn't that healthy. So clustering is where you look at the data and you find natural groups and bunches and clusters. So classification and clustering, as you can see, are very powerful algorithms that enable you to understand the hidden groups in data, hidden groups in consumers, that you say, oh wow, I didn't know that these people clustered around in this particular way. And that enables you to target advertising or messaging that is unique to a given cluster. Or if you find that customers classified in a certain way, you may uncover new customer segments that you never knew existed. So other than clustering and classification, the next big ML tool is regression. Regression is the oldest trick in the trade. When you had 2 points, Euclid said you can fit a straight line, and points that are close to them, if they are in the straight line, will follow a certain law. So regression is finding a mathematical description of the data. Knowing the inputs and knowing the outputs, you kind of have a regression model that will predict what the output is. And if the output is not what you predicted, you fine-tune the model until the model predicts your output perfectly. These are regression models. And the last bit, of course, as you would all guess, is optimization, right? Can you optimize something? What is the maximum value of something you are trying to do? What's the minimum value of trying to do something? So you try to maximize maybe your salary and maybe minimize the amount of hard work you do. That is an optimization algorithm we all use in our everyday life, right? So it's whether it is finding the fastest route to a train station or the quickest way to the office, or as Waze says, oh, knowing all the traffic that is out there on the road, can I find a path? Can I optimize the path to your office that takes the minimal amount of time, uses the most number of freeways, and avoids congestion the best? It's an optimization algorithm. So you find that clustering, classification, regression, and optimization are the primary tools in any toolbox of machine learning and artificial intelligence. Now, as you go through these, there are two big classes. One is what you call supervised learning and unsupervised learning. Well, supervised learning is where I tell you a set of good things, a set of things that have happened. That is to say, I tell you, this is the input and that was the output. And therefore, I teach you in a way how to classify things, how to cluster things, how to do the best kinds of regression. So it is supervised learning. The algorithms have a notion of what ground truth is, or have been told what is right, and they go try to figure models that do those things really well. Unsupervised learning is we just give it a whole bunch of data and say, knock yourself silly. We don't know what we are looking for. Come back and tell me if you found something. That is unsupervised learning. Well, as you would expect, supervised learning usually ends up producing a few more useful things than unsupervised learning. Unsupervised learning, when the algorithm randomly discovers patterns, sometimes are useful, sometimes are interesting, but sometimes may lead you to very erroneous conclusions, like when an Apple's traffic or map system asks you to drive your car into a lake because it detected something that was probably the fastest way to get there, and you say, oh my God, maybe some supervision is necessary. So if you look at the primary algorithms of ML and AI, they essentially boil down to clustering, classification, regression, and optimization, along with a level of either supervised learning or unsupervised learning.